uh, we are going to continue our lesson 4, and please look at pages 110 to 212. Um, Here, okay. So far, we learned about some types of electrolysis, electrolysis of molten compounds, electrolysis of solutions, and today we are going to continue for electrolysis of acid solution and electroplating. So uh, for electrolysis of acid solution, why does acid use in solution? Because sometimes based on the reaction, water is very poor for conducting the electricity. So we use battery for the electrolysis or any electric current. So sometimes water is not enough. So we need to add more acid to decompose the water, to break down the water molecule into ions. So that would be more a better conductor. Okay, the solution would be better conductor. Electrolysis of acid solution is look like this picture. Is like this picture. So we need to use uh, acid diluted in water, okay, in the tank. So uh, as same as the previous types, we need to use electricity current, which one side is the anode, is a positive charge, and the another side is a cathode. And once the solution moves through the pipe here, and they can react with the anode and cathode, the side in the anode side. So we have this reaction: two water molecule decompose to oxygen, produce oxygen gas, and for each 2 mole water produce 4 protons, 4 hydrogen cation, and 4 electron. So electron can react with anode. Okay, so and after that, this gas oxygen can release from the liquid, and it has converted to the actually gas form, and can release from the place here, and can be trapped. Okay, can be trapped in this area. And on the other side, in the cathode side, we have this reaction. So the what we call the proton which produce here, okay, the protons are also called hydrogen cation. Okay, hydrogen cation which produce here, and the electron which produce here, this side in the anode side, can move toward the cathode and react with cathode, and then produce the hydrogen gas. Okay, hydrogen gas, H2. Oxygen here can leave from the place, and the hydrogen gas can leave or release from the solution to here, this, and can be trapped here. So look at these um, two gas, oxygen gas and hydrogen gas, which they are trapped. So if you look carefully, you can see the hydrogen gas, the volume is more than oxygen. There is a question raised here why the volume of hydrogen gas is more than 2 times, about 2 times in oxygen gas. Okay, so this is the question from this part. How we can give this answer? We need to look at the molecule here, oxygen, and here hydrogen. If you compare the oxygen and hydrogen, you can see the hydrogen has 2 mole. In each reaction, each time reaction, hydrogen hydrogen gas is produced by 2 moles, double more than the oxygen, which oxygen gas has only one mole. Okay. So the production for the gas hydrogen would be two times more than two times in the oxygen gas. So another type of the electrolysis is electroplating. So electroplating, we need to have um, a container like this, tank of salt solution. The example of salt solution here is zinc sulfate. Okay, zinc sulfide here. So we have a cathode, anode as a usual, and there is a battery also. The battery to help the to make a current of electrons. So when sometimes why we use this electroplating method? This method is used to coat on surface of unreact metal. If you want to cover a metal, you have, for example, a metal, for example, any metal. You want to cover the metal with, for example, gold. Okay, you want to cover it nicely. So in atomic scale, so you can cover any unreactive metal in atomic scale, not simply by hand. Okay, this is very precise method to cover any metal, reactive metal actually. So we use a metal salt solution. Okay, the electrons can move toward the anode, which is zinc. Okay, so the metal being used to plate, and the zinc ion, okay, um, when the zinc here break down, okay, the zinc has been break down, the zinc ion can move towards the cathode. Okay, so this the battery can help to current the electrons, get electron from the anode here. When they get the electron from anode, actually zinc, the zinc positive part, the zinc ions, actually it's cations. Okay, it's a cation forms, it's a positive form, can move toward the cathode because there is electron here. Okay, there is electron current, so the cation, zinc cation, can move toward positive to the negative part. Okay, so the object is here. Okay, our target is here. Object metal to be plated, can be coated, covered by another type of metal. Okay, this is this method is good for coating on surface of any unreactive metal, like here any metals, using by another reactive metal like zinc here as an example. Okay, so this one, the electrolyte must be a solution of salt of metal in anode. Okay, all right, that's all for today. There is no question for this session. This is the last part of chapter 4. Then next time we will move on chapter 5. Please have a review, watch the video again for your memorization, and also look at your book to read for more details, and try to memorize time to time. Thank you so much. Take care and stay safe at home.